Okay, I guess let's start the session now. So I'm trying to contact Aarti ma'am, but I think she is not available right now. I guess she will be joining in some time. So, Amar sir, can we start?
Yes, we can start.
Yeah. So, okay. So, very good morning. A very good afternoon to all of you. Today we are gathered here to understand Azure console and advanced cloud methodologies with a guest speaker, Mr. Amar Kalvikatte sir. So, Mr. Amar Kalvikatte served as a network engineer at Alphatech Computers from July 2001 to April 2002. Then he worked for Tulip Telecom as a senior network engineer from May 2002 to June 2004. Engineer network management at Wipro, assistant system engineer at TCS from November 2004 to February 2007, and senior consultant at Capgemini from March 2008 to July 2013. Then he pursued an MBA degree from the University of Amsterdam Business School. He also served as a global cloud and DC network architect from August 2013 to October 2016, and a global senior manager from November 2016 to December 2019 at Liberty Global. He was a technology advisory member at INSEAD from July 2017 to October 2021. He was a member of the board advisors at the entrepreneurship cell at Pimpri Chinchwad College of Engineering from October 2020 to October 2021. Then he also served as a keynote speaker, panelist, and roundtable speaker at Auth Cloud, cloud solution architect in UK and Scotland from January 2020 to November 2021 at Nutanix. Currently, he is working as a senior pre-sales technical marketing at Aviatrix. He has a whole 21 years of experience in this industry and technology. So let's dwell into this session on the Azure console and try to get the best out of this 1 hour. Over to you, sir.
Yeah, thank you so much. Thank you so much. Let me share my presentation. Just see whether you can see it. Can you see my presentation?
Yes, sir, it's visible.
Okay. So uh, it's good morning for me. It's good afternoon for you. Thank you so much for giving me an opportunity to talk to you. I hope I'm audible enough to present. If you see any problem while speaking or any disturbances, let me know. I'll switch off my camera, which can consume more bandwidth. So I don't want to have some voice disturbance. So first of all, thank you so much again to be here with you all. Like I said, this session is, I know data, AI, machine learning. These are the new topics. So many things are there which I'm not sure in the colleges how they are currently pursuing in India. But obviously, unless you don't make your hands dirty, unless you don't know the nitty gritty stuff, it's very difficult to understand what is the data, how you play with it, how you write an algorithm to generate some outputs like dashboards, reports, or maybe something where the C-level people can take a decision on. So it's a long way to go, obviously, but it's good to understand what is cloud, why cloud has born, and then what are the offerings from different cloud providers. But especially we're going to talk about Microsoft because that's what we are here to understand what data platform they have, what are the different data offerings they do in the market, which are the important things which we need to take. So I made a small agenda, and if you listen to this 1 hour, roughly 1 hour podcast with a small lab, where you will have an opportunity to go to the console and showcase you how the solution you can build within Azure, or maybe same if somebody is interested in AWS or GCP or Alibaba, name it, Oracle. There are multiple cloud providers, but you can do that because cloud is the naming conventions are different, the pricing offerings are different, but behind the scene, the database is database, for example. Um, the naming conventions are different, their pricing options are different. So what I decided to do, since you are college students and I don't want to go in deep, because the cloud itself is so much to understand. You need to understand the mathematics where statistical analytical things really need to be thoroughly understand, right? And how regression analysis work, etc., etc. So I don't want to go those details. When you work on real time as a database administrator, as a data engineer or analyst, you will come to know what are your roles and responsibilities, how deeply you go there. So what I did is, since you're a student, and obviously anyone who really wants to pursue data engineering as a career, I think it's a good way to start with Microsoft Azure Data Fundamental. That's the reason I decided to start with the small kind of crash course for you. And with this certification, if you carefully listen and understand, you can even go and pass the 900 DP 900 exam. And basically D is stand for data. So whenever they say Azure AZ 900, that means the fundamental of the Azure. They have different naming conventions. So what we can do is, I played a small agenda for you. So what we're gonna talk about is obviously data challenges, but first I want to talk about cloud computing. Not much, like 5 minutes or maybe 10 minutes, just to clear what exactly the cloud is, what cloud is offering, why we have to think about cloud versus building application or databases or any data platform on premise. And then the core data concept within Azure, because we are talking Azure, so not to touch any other cloud providers. Then obviously the data is in different form. So how relational, non-relational data works, what are the tools are there. I'll tell you so that you don't need to worry about what I'm talking. I fragmented small pieces to clearly understand what the structured versus unstructured data is, what are the analytical workloads you can build, how you can build the pipeline. Then obviously security is very important. Without security, I think whatever you build has no value. So make sure that we comply with the security regulations, etc., whenever we build, because there are customers in financial services, customer in life sciences services, where customer data should not be violated. So we make sure the data security is key for us, not only for this course but also throughout your career. Security is a foundation layer. That means whatever you do, keep security always in mind. Then we will take a small lab. I There was a small error yesterday I was trying to build, but what I can do, like, maybe if the time allowed, 15 to 30 minutes, I'll showcase like how you build a database in Azure and go to the console. There are tricks and tips that I can showcase you to see like how um, user friendly UI, user interface they have built to build any kind of application within Azure. And then any questions based on the topic, happy to take it and happy to answer, which I know out of my experience. It sounds good to you? Anything you want to add, please raise your hand and I'll discuss on the topic without any problem. So three I want to touch three main concepts here, right? So one concept, as I said, the cloud. The cloud characteristics, which mainly you can imagine, right? Majority of times people are talking about on-premise solution, which is, that means customer are 50% of the customer are still on premise. That means they have their own data center. They have, if they don't have their own data center, they have leased the data center from some of the co-location providers, but still they're operating on premise. That means they are controlling everything. They're buying the devices, they're managing the operating system, application, middleware, name it, and they're also owning the data security. So obviously there are full control. But obviously there are a lot of problems which I'll come to you later. Then what Azure, of course, the what is Azure and what is the basic infrastructure Azure has built, what are the different services and offering, I'll touch to you very shortly. And then the third one is the important one, which we are here to listen, is about data. Like what are the different tools and different offerings in terms of price, for example, how Azure is differentiating amongst other competition like Amazon Web Services, Google Cloud Provider, or Oracle OCI, like Oracle Cloud Infrastructure, etc. And then we'll talk, um, wherever you feel like there is a something is not clear, make sure that you note it down, and at the end you can ask me a question on that slide. We can go back and make sure that everything is clear, because this presentation is not about me, or just because I'm conducting, is about you. And hope with this presentation you will take it back to your own project or own assignment in the near future that might help you. And also whenever you are presenting, you also get an idea like what is important. Generally I don't put any text in my presentation. I'll only put the pictures and explain it. But since the data platform is very new and very complex, I decided to put small text for you to understand if you are not clear, and if you really want to go back and listen again, I put it. So if you look at, um, we are talking about data, right? Data is information, right? We are gathering information from many sources. WhatsApp, we get every day different messages, right? Good morning messages, the happy Diwali message. By the way, for you, all of you, happy Diwali, and stay happy and healthy. So we are getting a lot of messages every single morning, afternoon. We are sharing the key information about college documents, assignment, etc., which is generating, obviously when the information comes, you need to have the storage, that information need to process. But we need to see like how you can write the algorithm on top to generate some outcome. Because why do you need to collect the data if you're not creating an outcome? Then there is a misuse of data, and you will see like how much percentage, if there is data, is also still wasted. So if you look at, when we talk about analytical data modeling, what we generally try to see how we combine different tables, different figures, and come up with some sort of model. For example, if you look at the number of different tables, we say, hey, this is a product, this is a time, and this is a customer, whether it's Joe's, Samir, whatever the names. And then we bring some algorithm or model based on this, and we say, hey, you know what, the total revenue sold by Samir January is higher, and this is the figure. So sometimes you can say, hey, some of the aggregate measures, and based on January and based on some other factors, maybe February, this is the outcome or revenue. So to give you idea, like this is what we generally do: collect the data from different sources, add the relationship between one versus another, because they're correlated, right? My point is there is a correlation, and every correlation you need to see like how you can, what exactly outcome you want to drive, right? Whether generating revenue versus some who's basically leading, who's lagging. For example, some of the, in the sales, for example, people say, hey, you know who has made more sales? Because there are millions of people. Let's say Amazon, Amazon as a company, there are millions of customers, employees across the globe. How to know that who was a top three performer across the globe? They run this analysis, for example. Or the customer issues, for example, if there are customer issues by, there are five major problems occurring across the globe. Let's say Netflix, for example, if there are many problems, people say, hey, the streaming is not working properly, there is buffering, a lot of issues, right? So they need to look at, okay, what are the top three issues happened, what are the major geographies impacted, and maybe like how we can overcome those. So they really want to know all those by collecting the data, right? If you look at the recommendation engines running by Netflix also, when you start watching action movies, he knows your data, right? What kind of likings you have, whether you like action movies, whether you like drama movies, or whether you like some other kind of movies. they really know, and they really recommend you the next movie which is similar exactly or 80% similar what exactly you like it or you watched it in previously. So they are really doing like data, uh, AI, machine learning kind of algorithm, let's say modeling, and they're creating the value for customers. Because at the end of the day, what we are doing is creating value for customers because they're buying and we are getting the money in the business, right? So that's very important to understand. So when you look at, obviously companies generate the outcome, as I said, like some people say, hey, I want to know the tables, I want to know bar chart, some people line chart to showcase to their management about, hey, this is the data collected, this was the outcome. Maybe you see like, hey, how many let's say it's hardware versus tools, and then we are we have more tools than, let's say, hardware, or hardware are more than tools. You come to some sort of a conclusion, and then you put those data points in front of the management, because management has very less time to listen to your story. They have 30 minutes. CEO doesn't have much time. He might be traveling, he might be working with customers, and before he goes to the customer, he really need consolidated data, so that he can immediately go through while traveling or while he's in flight, and then present the data in front of a customer. And the same, like if you look at Maharashtra's chief minister, he's traveling here and there, he need to have the consolidated data before he can make any statement in front of the public, right? So my point is, these are the graphs or plots or maps and everything. That consolidated information is a key to drive. Even if you're collecting the let's say, now we are not talking about gigabyte of data or petabyte, terabyte of data. It's all about hexabyte of data, and exponentially that is going to be zettabyte of data. So that means we are tremendously creating data, and will show you like what are the medias where majority of data will be generated. So, as I said about data, but we need to understand the cloud with Azure or AWS or whatever. But Azure, for example, why cloud? We are talking about all this analytical modeling. We're talking about data visualization in terms of reports or dashboards or some sort of decision making. But how that data will be collected, processed, and basically bring the outcome, you need a platform, right? You need a platform, and that platform is cloud computing. And there are different models, service models, and as well as there are different types of cloud methodologies. Will come to know, and you will understand like when you become tomorrow's CEO, CTO, or CIO, how you make that decision rationally, not irrationally, rationally, to add the impact to the customers and your business. So look at the cloud computing. Obviously cloud computing is a small word, but obviously just one thing to be mentioned is cloud computing is nothing but a data center, right? A data center which you previously, as I said, on premise means you were buying the equipments, you are racking, stacking, configuring, maintaining, as well as financing continuously, because when the device is plugged, is consuming electricity, you need cooling, all those the costs is you are bearing as a business. But cloud is a different model. They say, you know what, you don't need to worry about building data centers. What you need to do is focus on your core business. If there is an application you are offering to the end customer, like Netflix, previously they were maintaining more than hundreds of data centers on their own, but they realized that when there is a problem, we cannot solve that problem within an hour. Even if the data center is burned out, we cannot move that data center from one place to another and build it within couple of days. So I will be losing my customers. They will be moving from Netflix to Amazon Prime or maybe someone else, and I don't want to lose the customer. If the customer is lose, means you're losing the business, you're losing the recurring revenue, the monthly subscription or yearly subscription, whatever you have it. And they don't want to lose. Customer is very important, right? If you lose a customer, whether the trust, whether um, the satisfaction, I think whatever things you are doing, not today but tomorrow in your career, um, make sure that you don't want to be a liability for a company, rather than you want to be an asset. So to create an asset means you are adding value to the customers. So what is cloud actually? So before going to the cloud computing, you need to understand who are the cloud providers. So there are a bunch of cloud providers, right? If you look at AWS, Azure, GCP, and I'm not saying AWS is better or Azure better. It depends on the business requirement, depends on the technical or non-functional functional requirement. So let's assume that if your customer who already has their business running on premise. So let's say I'm a Netflix today and I'm offering the videos or all the movies by streaming on my data center, right? But the thing is, like, my majority of the data, the Netflix applications running on the Windows based infrastructure on premise. So I have the Windows operating system, I have the Windows servers, my team or skill set is Windows based, because they know how to handle manage the Windows environment. If I have to disconnect or decommission that data center and move to the cloud, the obvious choice is Azure, because you already have the knowledge and the skill set within your team, but also you have the infrastructure which you know exactly how to take it into that particular cloud, and basically start rolling out the same business without any kind of discrepancies, right? The same thing it goes, but different obviously. If there another differentiator could be, hey, you know what, why should I go to AWS versus Azure if I want to adopt a pass? Which one is the best one? If, say, AWS started by building infrastructure as a service, and they were really ahead of the curve among all these cloud providers. When Azure realized, or Satya Nadella, who's a Microsoft CEO and chairman, realized, like, hey, you know what? If we have to be in the cloud space, it's better to reinvent our wheel into the platform as a service, not the infrastructure service. Because infrastructure as a service, the market share means number of geographies, number of customer across the globe, has already taken care by AWS. So if I jump into that pool, I will be get minimum number of customers. That means the market share, and I won't be making business even if I'm making my huge investment. So when they make investment, you need to see, like, what is my ROI, return of investment, because the shareholders are investing in your business, and you need to see, like, who how much they are getting. So if you buy a house for let's say 1 crore, and tomorrow want to sell after 3 years, and if you're not getting more than 1 crore, you are not creating the return of investment. You should create some the money out of it in the business, right? Airbnb doing the same thing. Many customers are doing the same thing. So we need to, the shareholder need to see what is my ROI, and that is how the business runs, right? So if you want to build your infrastructure on public cloud, obviously there are Alibaba or IBM also creating nowadays the public cloud, and hopefully they will catch the waves among these. But if you look at majority Asia Pac, right? Maybe the Asia and the Asia Pac region, where the Japan or Australia or New Zealand, that area, Alibaba is leading provider, because they have created, they don't want to go across globe. They really want to cover that Asia Pac region. They are leading. If you look at AWS, Europe and US, they're really the market leaders, but especially in the infrastructure service. If you look at platform as a service, Azure is taking the lead. Then you ask, like, what is GCP is doing? If you look at GCP is main focus is really on the SaaS offering, as well as the AI machine learning, right? Because if you look at Google Maps, it's not new, right? 20 years they're operating Google Maps. If you search my street name here, you exactly get the view of my house, where my car is standing today. That is real time view. So that means the Google is already operating IoT, which is sensor based, because they're putting sensors already. They know exactly what is the street look like. If there is a work going on the street, the I should forgot to put the picture. The car goes every week to get the picture, and automatically it detects that if there is a changes, they only add that particular picture, and then automatically modify the street view. So the sensors, IoT, data analytics, machine learning, AI, it's not new. Google is using for 20 years already. But obviously the buzzword popped up now. The technology has been created. Google were not offering. They also decided, hey, who want to go buy in the future? But now everybody is creating. But they decided to move their focus on AI machine learning. So everybody has created their way of offering. If you look at Oracle, Oracle is obviously they started their business as a database as a service. right? And mainly the relational database, where there is a tables, there is a rows and columns, and there is a particular schema. So banking application, if you look at, where you need massive amount, because bank has millions of customers, they need to put the very mission critical data. Let's say Amar Kalvikatte, my home address, my credit card details, all those, and that should not be violated to any hacker or any outside world. It should known to the particular user and the bank. So those critical information which are latency sensitive, high performance application, even if you're ordering, automatically it attach your credit card information and make that order done and shipped, right? So all those things, there is a purpose, right? Why they are creating this cloud, there is a purpose. They also knew that where they're good at, and they need to focus on their niche offering and capability, and they need to move on. If you look at IBM, as I said, they will be moving soon into this space. But IBM, they knew that they had a lot of acquisition, they were surviving. Meanwhile, they didn't know like how to take the company forward. Then Krishna, the new CEO, has taken, and exactly knew, as he worked more than 30 years in that company, like where we are good at and how we combine our solution, how we integrate solution. The companies they acquired, like Red Hat, for example, Ansible, so many companies they acquired, how they can combine and go to the market and offer new services to the customer that is competent to these cloud providers. Maybe on-premise, maybe the integration of public and on-premise, that is hybrid, or maybe how they can customer take, if there is IBM infrastructure and they can pull out to the public cloud. They started getting that business, and if you look at now, 20%, I think, year over year growth they made it. I just read a couple of days back their financial statement. That means they're taking the pace, they're creating competition with this provider, which is good for the customers. If there is a competition, it's good, because we get best out of the best. If there is no competition, then they will say, hey, you know what, customer are buying, we are, whatever we're doing, we don't need to spend anything more. um, which is bad, right? But also customer doesn't get the new feature, new functionality, new offering, competition. If Diwali has come, Amazon, Flipkart says, hey, you know what, if you 20% are discount on Amazon, Flipkart says 25%, because there is a competition which is benefiting to the customer. Customer is getting more offerings, more discounts, etc. Right? So I don't want to spend more time, but I know what I'm talking, and you're getting the message. So there are on-premise providers which are private, public. The combine is hybrid. So, and also if you mix two different cloud providers, and you are still building your application that is multi-cloud, I'll come to that. So what is the cloud computing, right? As I said to you, it's a data center. But data center which you were operating on premise, or the data center which is built by the cloud providers for you. So if you look at the data centers which we are operating in last 30, 40 years, it was a spaghetti, right? It was complete spaghetti, meaning if you look at, if you really, somebody said, hey, my server is my server is unreachable, and there was probably, I don't see, if somebody's pinging from the as a network engineer, he was pinging and trying to telnet or SSH, or maybe taking that server account. He said, hey, you know what, I can't reach to that server. So the network engineer or whoever who's managing the data center is trying to say, hey, look, like there is a plug, cable has plugged out, but which cable? Finding the cable and tracing the cable, it takes ages, right? So the problem, to 1 minute problem becomes 3 hours, 3 days, I don't know. It goes on and on. The customer, look at the customer satisfaction, who's want to do the billing. It's a today's last day of submitting something, and that's the server you need to go and make your payment, right? Look at the customer experience is not delightful. They will be unhappy with your service. They don't like you, and they might say, you know what, this is the last time I'm going to make a transaction, I'm moving to some other who's giving me better. Let's say the application always available, always highly performant, they're secure. But look at, if you operate as your own data center, this is the situation, with no structure, nothing, etc. So obviously this is one of the reason also people are moving to the cloud, because if you look at cloud is nitty-gritty compared to this one. If you look at, you don't even see the cables. Its cables are tightly and properly and racked and stacked. behind the rear view, I would say, not in the front view, rear view. And you would see the similar kind of servers. It's a scale we called in the cloud spaces scale. What they do, Amazon, AWS, Azure, name it, Microsoft, what the engineer or the data center guys does, they take the rack. Every rack has a similar structure. You don't even see the difference. Maybe the tagging on the top may be different, like, hey, rack number 1, 2, 3, and maybe the serial numbers where the tag numbers, hey, this server 1, 2, when they want to obviously troubleshoot when there are issues. So they knew like their naming conventions, the rack number, the stack number, the server on which position. So whenever they want to go physically and troubleshoot, they exactly know, right? The cable is properly plugged in, everything is there. The important point is not about this one, but they own everything. The cloud providers buy the servers, they rack it, stack it, they patch it. They take the ownership of maintaining the data center. It's not about you as a customer take the ownership, they take the ownership. What you focus as a customer is on your application, on your core business to offer to your end users, whether it's B2C, business to consumers, which is every individual, or business to business, like business to many corporations, right? Then what are the different offerings you give? So you focus on that business because you're good at that. You're not good at maintaining data center, building data center, managing the network storage, compute, etc. You That's a specialty of cloud providers. So if you look at data center of your own versus data center of Microsoft Azure, which is in Arizona or maybe Amsterdam, you will see the similar structure. They are very. So what they have done is, if you look at when they build their data center, the data center, you should look at the data itself, right? The center for collect, basically putting your data, right? At the end of the day, otherwise you say, hey, where we data we are talking and where he's going, you need to understand also. So the data where you put at the central location, these are the data centers. And these data centers are very important in terms of geography also, where you're building this data center from outside the flood. If there is a water flood, you should not be impacted. You should keep it away from the flight area, because if there's a flight landing, it should not by mistake, whether there is a air or there is some type of turbulence that might affect to move your flight and bombard on your data center. So you need to be also think, as when you're building or they're building, whether obviously it is also important that if there is a fire, the fire brigade, all the facilities are close by. If there is electricity, how we can use that green electricity, they call carbon neutral, right? Everybody's talking carbon neutral, like how they can create carbon neutral data center where there is a less emissions into the space as well as in the area, so that there is no uh, pollution violated. So all those nitty gritty stuff they look at. Plus they said, hey, you know what, I want to comply with the regulations, the SOC compliance, the PCI compliance, the name it, right? To be sure that I'm not violating any of the regulations, whether Indian Cloud or Data Act, GDPR, which is General Data Protection within Europe, Cloud Act within US. So making sure that we are not basically violating any regulations or compliance. So they already have the high vision, they build in that way, like this massive data centers, adding capacity and scale. And obviously they're building this data center across the globe. That means they're creating regions means a specific location where they start building data center. Every region has multiple data centers. So one, this is unavailable, maybe 10 miles away there is another one, they automatically fail over without customer notice, and customer don't even see like my application is unavailable or there is a performance issue. That is hidden behind the scene, and they run the magic like auto scaling, etc., to be sure that your application is always available and always bound to the SLA, service level agreements. So if you look at cloud computing, obviously cloud computing, they are offering compute services, network storage, database, so many services they're offering, but they're creating a platform which you can build any sort of application, whether it's SAP HANA based application, Oracle database application, ERP application, CRM, customer relationship management, all kind of application that you can build without buying and racking and stacking servers, right? You just swap your credit card. You start once the billing is they knew that validate billing validation is done against your name. It's right credit card number. There's enough credit on it to purchase the services. They validate that, then you're good to go within minutes and hours. And what exactly the offer is, they help you to innovate faster, right? What does that means? If you look at, if you want to build in a small application, web application, let's say, if I want to build in a website, I need to buy, for example, if you go to GoDaddy, first buy the domain. Then after buying a domain, you said, hey, I want to host it. So I said, I go for wordpress.com or something else to host my application. Then you write your own code. Then you put your own images, which all those need to it takes time, right? So what cloud provider said, hey, you don't need to worry about. You can in a minute, the moment you know your domain name, we give the public IP, everything will be sorted. You can even put your images or website directly on the object storage, uh, which is very static in nature, and you can build your website within an hour or a day, rather than putting days and months behind the scene. So they are like doing that kind of innovation very faster. Flexible resources, meaning you can take compute storage, depends on your need, and you can only pay for what you're using, right? And as I said, economies of scale means they are basically building the data centers, right? And economies of scale means what? The more you buy, the more less you pay, right? Because you're buying in bulk. There is offer, right? Buy two get one free. So that is the economies of scale, where you have, the more you buy, it's good for consumer, but also they are building it with scale. And that kind of offering they want to put in front of the customers. So basically this is a leasing a car, right? You lease a car, you use it. When your car is handed over, you stop billing. You go to Airbnb, you rent for one day, you stay happily. Once you check out, your billing stops, right? And the billing means it's like hotel also, like you might have go to the canteen, you might have fetch some snacks, chocolates, and you pay for it at the end of the day before you close out. And then you are done. You don't need to, you're not owning that hotel. My point is, you're not owning that hotel, you're not owning that Airbnb room, or you're not owning the lease car. You just own the car for a specific time moment. So that is called pay as you go model, and that is operating cost. I'll come to you that later. So there are four types of cloud computing. Probably you say, hey, there is a three, where is the fourth? But I'll come to you. So the public cloud, as I said, public cloud, which are Amazon Web Services, Azure, name it, like these are the four public cloud. The private cloud, where you have your own data center. That is, you can build with VMware, Nutanix, IBM, name it. You buy those equipments, you build it. When you make combination, say some customers say, what, I don't want to put my database server into the public cloud because there is data sovereignty issues. Maybe government of India will say, what, I don't want the financial companies like ICICI Bank, HDFC Bank, or any kind of or state bank that should put their customer or critical data into the public cloud. So they say, what, I can put my web, mobile, and front end application in the public cloud, but I create a back end or a UI, or maybe like, let's say integration, or um, let's put that way, in a way, like interfacing to fetch the data, the customer data, the backend data, let's put that way, in a private cloud, because that is in my data center, which I am not violating the Indian Data Protect Act regulation. I don't know exact act, but just assume that Indian Data Protect Act, I'm not violating. So I'll keep my database server into, and the Active Directory server into on premise, and the rest front end, and maybe the database, sorry, the object storage, all kind of facility into the public cloud, because it's not cheap, but also I can add the scalability. I can, if there is a number of users coming, I don't need to add new servers, it automatically taken care of. So the combination of, they use it hybrid cloud. When there is a customer say, what, I want compute from AWS, I want database from Oracle Cloud, or maybe something else. So if they use combination of multiple cloud, that multiple providers, that is become multi cloud. When your application spread across multiple clouds, they call multi-cloud. Which is the fourth one? Probably you say, where is the fourth one? That is multi-cloud. Obviously the naming conventions go on and on, but in my opinion, multi-cloud is a hybrid cloud, because you're using two different clouds and you're combining. That's hybrid at the end, whether it's private or public or one cloud to another. At the end of the day, hybrid, and that hybrid will stay always there. Trust me. Hybrid meaning not only on premise but also between two clouds. So hybrid cloud of the nature will always stay. Now this is very important. Obviously you might say we can understand the data and data related stuff, but very important to understand the service types. So service means what? Infrastructure service, platform as a service, software as a service, and why they named it that way. It's very important to understand the roles and the responsibility. Keep in mind, when they offer cloud providers, it is always a shared responsibility. Shared means you own something, they own something. So if you look at when I talked about your own spaghetti data center, where you were owning everything, you are managing everything. That means the networking, storage, virtualization, OS, middleware, runtime, data, application, security, all those nitty gritty stuff. You're buying, you're owning, you're maintaining, and you are surviving if something goes wrong. Now think about these three provide. Obviously, this IaaS PaaS all public cloud providers offers. So you take it. This is a common model. So when you take infrastructure as a service, they decided why you take infrastructure as a service. The reason. Let's assume that you're migrating your legacy data center to the public cloud. As I said, your team who's already running your application and business, you don't want to throw them out of your business because you're moving to the cloud. Why? Because they have the knowledge about their operating system, middleware, runtime, the virtualization server storage. You don't care. You say, hey, I don't want to care, but I know that my operating system, because already I purchased Microsoft licenses, which is valid for next 3 years. If I go to the past, then I'm whatever investment I made for OS, middleware, runtime, that's gone. So why should I make that investment into the recycle bin rather than I use it for next 3 years, and maybe next 3 years I will completely move my IS to the past. So what they do, they migrate to the infrastructure service. While they're doing that, they also knew that my team will also help to that migration because they have knowledge about all those platforms, right? I hope that is clear. When the company said, you know what, I want to my, because I'm into the IaaS, I'm into the public cloud already, I'm into the IaaS, but what happened is I still want to not to manage operating system, and I'm not bound with any operating system. I don't care what is my underlying operating system. Is it Windows, Linux, Ubuntu, name it. There are Red Hat Linux, many Linux flavors are there. Why should I have to worry about? Then Apple has their iOS. So why should I have to care about the operating system? I don't care. What I care is application and my data. So they focus towards the platform or service. They migrate it, right? Some people, and we are using, like, look, Google, the Hangout, or Google Gmail, or name it, right? There are so many applications we are consuming. We are not working on it. We are not building the front end, back end, and we are not working. What When you log into the gmail.com, what you do, you put your username and password, you have your emails, you have your files and everything. You are not managing, somebody's managing. You are consuming that application. That is called software as a services, where everything is taken care by the cloud providers. The orange part is taken care by the cloud providers, and the green part you as a customer manage it. Yeah. So in the IaaS you manage OS to the application. In the past you manage data and application only, and the SaaS you don't manage anything. You rather consume it, whether it's Office 365 application, Zoom application, Dropbox, name it, right? Those applications you take it into account. You purchase it, you work on it, you add numbers. Hey, Office 365, I want thousands of users. They don't, you don't worry at all. My um, inbox is full, I need to delete. They add on. The more storage you use, the more charging will be happen to you. But you don't need to worry about, hey, I have to clear my messages, I have to remove my files from promotion or trash and everything. You don't need to worry. The scale is already there. So that is the benefit. Customer gets it or user gets it. So before we go and talk to the data now, it's very important to understand the financial point of view, because business is a finance at the end of the day. If Sardar Patel College of Engineering or any college of engineering, it's a business for the investors, right? Don't take me wrong. If there is no students, there is no use of college, there is no use of professors, there is no use of brand as a Sardar Patel, right? It's a government entity or non-government, they're creating business. If you're not paying the fees, the professor doesn't get their salaries, and the college doesn't make the benefit. And you are customers, right? The students are customers, they should be well respected in the college, and professors also should respect to the students. Rather than this, of course, it goes two ways, but because customers are very important. Don't take me wrong, I'm not going in a different direction, but make sure that customers are all highly valued, highly given more weightage, because without customers there is no use of business. If I create a product and nobody is buying, what is use of that product? Yeah. So make sure that product has value, but also the customer has more value. They are helping us to make new feature, new functionalities, because they're giving their feedback. Hey Zinat, hey, iOS is better, Android better. They tell you the pros and cons. You take that cons and you make it pros. You work on your weaknesses and make it strength, and work on creating an opportunity for customers and your business. So make sure that you are creating that. And importantly to look at is how you work with the customer. When you work in your early career, don't focus on, oh, I'm a technical guy, Java guy, coding guy, data guy. That is a bad mindset if you make it from the day one. So when you, if you go to customer and start working, try to understand how they operate on a financial. For example, capex versus opex. So capex means initial investment. When you're building data center, as I said, you buy everything. You buy server, storage, network, name it, you buy everything. So you put your initial investment, right? Or if you buy your own house, you put your money, you invest your money. Plus opex, operating cost, when you have electricity, the gas bill, all your maintaining your house, that is operate ongoing cost, the variable cost, which you have to incur every single month, right? And the capex is initial investment. Whatever you buy mobile, that's the initial investment, but you need to maintain. So you buy the cover, you buy some protection stuff, you purchase something there, you put electricity, which also cost you. So all the operating costs, ongoing costs. If you look at cloud is operating on the opex. So that means the customer should not worry about capex. Even if I'm a startup and I want to create my website or put something, I don't need to purchase any server. I don't need to purchase any expertise of managing that server. Rather, I go to the public cloud. I build my codes. I have the codes. I build those code in the GitHub, and then I fork it. I use it, and I say, you know what? Let's build my website and make it available within a day. What I'm consuming behind the scene, I'm consuming the compute power, the storage power, and some sort of networking stuff with public IP, internet, public IP, which costs money, of course. But then you allow add the SSL certificate, say https.aturcloud.com, where you get an opportunity to make that access to the customer. So what I'm using, I'm paying the resources I used, and only being charged for that resources. When I close all the resources, my billing stops. Make sure that the billing stop. Like I said, the moment you check out from the hotel or the Airbnb room, you no more charge. You are no more obligated to pay back. So that is a finance step. And always understand the finance. If you don't understand the finance, forget you're a great Java coder, machine learning coders has zero value. Yeah. So make sure that you understand the finance, because business is equal to finance. Business equal to the top line, which is sales. Business is equal to the bottom line, which is P&L, which is profit and loss. Nobody want to see the loss in the future or in the today's environment, right? They want to see the profit. That means they want to see like how many customers, how many business with the data analytics, what sort of data we collected, what we generated on top of data. They want to see the value, and the value comes in terms of the price. Yeah. So hope that is clear. Now we'll touch to the, and like I said, the data. Before I go one slide further on the data, You need to understand, as I said, it's a shared responsibility, right? If you as a customer own every step of the business, so the cloud providers take care of the data center, CCTV cameras, locking the racks, particularly so that nobody can go into the rack, switch off the servers or take the cable out. Nobody does that. So they keep that security or physical security tied to themselves, where you never go to their data centers. You don't know exactly where server in data center 1 2 3 within that region or geography. You don't even know that. So they take care of it. That's the shared responsibility. They take something, and the data, the encryption, the basically applying access policies, rules, all that is the customer or your own responsibility. So that means it's a shared responsibility. Just to be clear, right? If you're clear in the cloud and the responsibilities, I think it's good to focus on the key or niche things like data or AI or machine learning. So now, um, just I put this slide to understand also, because you when you go for an exam, if let's say DP 900, you should also know what are the basic functionalities of compute, storage, network, etc. So if you look at compute, Azure offer four different flavors. Azure virtual machines is in general virtual machines, which is on-premise similar, but as I said, the virtual machines come with different operating system also. Nowadays, Microsoft is not offering only Windows, but you can take Linux, etc. Different price with two virtual CPU, 10 terabyte of storage, 1 terabyte of storage, or depends what you needed. So it comes with our memory, for example. So it comes with the package. If you go to Azure App Service, which is a platform, this is infrastructure as a service, because we virtual machines means you are also managing the operating system. If you Azure App Service, which is platform as a service, you're not managing operating system. You're only focused on data and application. But obviously, it comes with a cost, because if they are managing the OS, middleware, etc., they also need to take the cost out of you. It's still expensive, but you are still moving to the platform service. So if you look, if you want to build an application on top of platform as a service, you forget about virtual machine, go on app service. Simple. If somebody said, hey, you know what, I want microservices application to be built. What is microservices? The small services which is compared. So for example, if there is an elephant, you cannot move that elephant. If the elephant has some problem, the elephant cannot be moved, right? But if you cut that elephant in 10 pieces, you can move one part of, like elephant is let's say 100 kilo, you cannot take the 100 kilo. But if you cut that elephant into 10 kilo each and 10 pieces, you can take 10 times and you go and plug it again at the destination end, right? So you basically create those containers and make sure that you use that containers and use that service. It's a decoupled services, not coupled, because if coupled means if it's a monolithic or waterfall approach, where if one fails, everything fails. In the Kubernetes, or let's say Docker or anything, Kubernetes is orchestration, but you can have the container from Docker and Rancher, Red Hat, name it. But that is a runtime environment. But really, the orchestration is um, from the Kubernetes, where you build the decoupled architecture. If Azure function people, it's also platform as a service, but function means what? You write a code. When there's an event come, that event, you know that the event might be shutting that server after 5 minutes, but you don't want to shut that server in 5 minutes. The moment the 5 minutes is touching, what you do, you write a code. You already write a code, but you make a provision in the Azure function that, hey, when the time comes to the 5 minutes, just run that script, so that the 5 minute become again an hour, so your server never shut. Or maybe you want to write something, hey, you know what, I'm using the server, make sure that if there is no traffic less than 10%, if there is traffic less than 10%, make sure that shut the server. So write the script. So that is where this server Azure function, or AWS they called Lambda function. So they that has been used majority of times. When we talk about data, obviously the data means storage, right? If you look at my mobile or your mobile, obviously mobile doesn't have the storage hard disk or SSD disk. It has a memory, right? Because why memory? Because there are n number of applications which are WhatsApp or Instagram or name it. They're running, they need high processing, like low latency, high performing response. So it runs on a memory, because memory is very fast in compared to the rest of the storage. So that's the reason we said, hey, 65 kbps or um, sorry, 64 GB or 32 GB or 8 GB, whatever called, we go based on memory. Obviously memory is also a data store, right? It's not like it's a different step. Memory is also a data store. So obviously you put your data, whether you put raw data, and data has number, like whatever data it comes is becomes raw. You don't know whether it's a relational, non relational, because you start collecting data. So the raw data which comes in the files, videos, etc., it goes to the blob storage. Blob storage is the object storage. Is, if you look at Amazon, they called S3 bucket. If you call it Google, it's called Google Cloud Storage, which is object storage. Then it file storage. File is, when you work in the, let's say, college said, hey, I shared the folder and there are the document in that folder, because let's say Arti madam said, hey, I'm teaching a database service and I put all the presentation slides on that folder. You go on the network and access it. That's a network file storage. Somebody put on the network and you have to be on the network, same local area network or wide area network, to access that file. It's a structure, hierarchical, right? You have the folder has another folder has the files. For example, it is hierarchical. If you look at uh, data lake storage, I'll come to that later because it's important, like how it's a similar part, because but the has different architecture. I'll come to that later in few slides. If you look at relational database is what has a relationship, like a table has rows and column. Amar Kalvikatte, my attributes into column is address, credit card number, maybe age, for example. All these rows has column and they are correlated each other, right? That's particular schema. So as what Azure offers is SQL data, but as a, they're obviously they have their own database. But if customer said, hey, I want open source databases, they can use MariaDB, MySQL, Postgres, and they have no limitations for end users who wants to build open source technologies. If you look at NoSQL, NoSQL means what? Document database, right? Like Cosmos DB, for example, or DynamoDB in AWS. So all those databases which are fully documented, that has no structure, right? And that you can keep it into the NoSQL or Cosmos DB, and I'll come to know specific on this data side. And you will understand like what is a very like how you use it, what kind of scale they have, what are the different pricing, etc. Look, networking is very important, right? You, when you send a packet from your WhatsApp, let's say you say hi to me from India and I'm sitting in Netherlands. So you need a network, even if it is a wireless. My mobile is connected by wireless, but connected to my modem. And the modem has a really physical cable, and that going to the switches to the router to the MPLS WAN network across multiple telcos. Whether is, let's say, Geo in India is already paired with, let's say, Liberty Global, where I was working as a company as a telco. We share the packets, we share the data, and we give it to the end user. So without network is impossible. So if you look at AWS, they have all the data centers which they are connected with the fiber optic cable, very high, like 1 terabyte interfaces, 100 gigs pipes bundled with 1 terabyte, throwing the packet one end to another, and they're building their data centers, right? But when you build an application, first and foremost thing you have to create, even if you're placing database or computer or network as a computer storage or any kind of integration, whether API based or non API based, or storage accounts, first and foremost thing you have to build is a VNet or virtual network, right? When you have one virtual network in, let's say, India region, another virtual network into the Europe region, they need to be paired or need to connect it internally, not externally. That is called VPC or VNet peering. The VPC used by AWS and Azure or GCP, no, sorry, GCP, or even Alibaba. VNet or virtual network is just same thing, but the naming convention are different by Microsoft Azure. If you look at VPN, what is VPN? If you have the data center on premise and your public cloud, and you want your app server database should connect to your app server over the internet, but securely. Securely means end-to-end traffic is encrypted. That is the virtual, you build a virtual private network, which is private, but it's fully encrypted. But obviously the bandwidth you get is minimal, 1.4 gig, I believe so. But when you build the express route, you build the lease line between. That means you own the pipe. It's not over the internet, it's yours. You build via public service, sorry, public providers, whether Geo or Tata or some other providers who's offering the data center service, or maybe MPLS service. You take the connection, 10 gig, 500 MB, depends on your business needs. You build the dedicated pipe. The benefit is you can build resilience, high performance network, but the problem is comes with a cost, because you're consuming more bandwidth, and it is like a fixed cost, and you have to bear it every month if there is a fixed contract which you have to go through. So also expensive solution. Obviously when you build everything, you need to monitor, like my application, what happening with that application. So I'm monitoring the network analysis, I'm monitoring the CPU utilization, memory utilization of that. So somebody need to monitor, so they have Azure Monitor, which monitor every single step. If the data is going from source A to source B, and then there is a whether it's a batch data, streaming data, or real time data, you need to see like where is the bottleneck, where my data is getting stuck, who needs, you don't know, like you don't know what's happening between Europe and India. So Azure monitors will tell you what are the issues in the compute space with the memory, CPU utilization, what network utilization, with net flows and analysis. Security center, where as I said, security is very important. You need to manage your encryption, you need to manage your access policies. You can manage from security center. There are different tools also, right? uh, even the even the Sentinel, or some sort of different tools you can use. You can use load balancer, you can use firewalls, name it. So these are the offerings cloud provider does. Now I talked roughly about an hour. I roughly touch couple of minutes to focus on data, right? And the migration. If you look at migration, there are a couple of Azure migration tool, Active Directory for users to only allow to the resources. If say administrator have full access, so he access anything. If let's say Amar as a user only access the database, so I only access to the database. So user have the groups added in the group has an access to that particular resources. So that's the reason it's Active Directory, which is they call nowadays IAM, infos as a identity and access management. That means the identity, which is Amar, has an access to particular resource. So authentication, authorization happens to the Active Directory. If you look at DevOps, obviously, as I said, the CDN is CDN, content delivery networks. You are creating DevOps is like Kubernetes services. You are writing CI/CD pipeline, continuous integration, continuous delivery with the help of Jenkins, Ansible, Terraform, name it. There are so many tools out there which you can use it and run your DevOps practice. Analytics. This is the focus we have today. I'm sure you might have think, hey, we need to talk about data, but unless you don't understand this foundation of a cloud and why cloud, then I think understanding just data doesn't make sense. So obviously AWS has Azure, Microsoft Azure has many data related tools and offerings. But look at why data, right? We I mean, when I started my career in 2001, after passing my bachelor of engineering, um, we are not talking about data, we're talking about applications. Now application names are changed, workloads. I don't know, after 10 years workloads name might change into different else. People want something changed, right? That is called transformation. Data, we didn't know that we are not even taking care of any kind of data. We are not generating revenue, we are not generating dashboards. But since Google and some other companies had born with that data step, as I said, Google is the only company who already in more into the AI and machine learning and data analytics than anybody in that. But obviously everybody's putting hiring engineers and architects or scientists from GCP, paying highly to build that service within AWS and some other cloud providers. That's what rotational stuff are happening to build their compatibilities. But what is data actually? Why data is important? People calling, if you look, maybe there are multiple sentences coming. Hey, data is new oil, data is new currency. At the end of the day, that means data is generating some business opportunities. Data is generating some decision makings, right? And that is more valuable for customers at the end of the day. It's not about business. If the customers are happy, if the customer are buying, your business is healthy, your shareholders are healthy. Shareholders means someone who's investing continuously in your business. They're multiplying their investment. If they invest 1 million and you're making, because you're adding more customers, you're giving them as a dividend, or as a let's say, if they're sh- selling back their shares, they're getting 4 5 million. That means they're multiplied their investment by 4 5 times. That's the value of data. That's where you want to generate the businesses, and at the end add value to the customers. So if you look at, as per the I went to the Foster to grab these slides just to understand how data critical things are, because these figures are very important. If you look at the 60% of IT spend, half or more than half of the time on data quality of assurance and the cleanup and preparation. So people don't know, right? Like, if say somebody said, hey, I have the data, but what quality things I want to drive, what quality assurance I really need to build, and what kind of preparation and cleanup I need to do. Cleanup means if I'm not using the data which is vested or filtered, I need to clean it up. People are focusing 60% of their time on that. That means it's a waste. 40% is value added, 60% is waste. If you look at 450 billion dollars, it's big amount, right? It's big spend. They are working on data preparation. It's hell lot of money, trust me. And if you look at the Forrester, this is very important point, is between 60 to 73% all generated data remains unused for analytics. That means you are collecting data, you're processing, but you're still not using that 70% mark. That means why you're doing this exercise, right? These are the findings. These are the things Forrester, IDC, Gartner, they do it. They go to the customer, they understand what customer is currently up to, what is their analytical and data, like AI machine kind of thing, where are they in their journey. All the data they collect, they process it, and they bring this kind of reports to every individual. So any customer wants to go into that journey, they always go to this kind of Forrester, Gartner, or IDC reports, and see whether we are not first or making mistakes, so they get that idea before they start proceeding. If you look at unleashing the data in economy terms, right? And I put into the Microsoft fashion just to make match those colors. If you look at, the data is generating every single day in enormous numbers, right? The terabyte, the hexabyte, databyte, it's every day. If you look at mobile apps, we have billions of mobiles that generating billions of like trillions of data every single day, right? We're sending WhatsApp messages, Instagram messages, Twitter messages, Facebook, LinkedIn, name it. Yeah. If you look at social media, as I said to you, that LinkedIn, Facebook, Instagram, that generating. If you look at IoT, now every dumb device is going to be smart device. Why? Because my refrigerator, which I don't know what is filled in, what is not filled in, tomorrow it will be on the network with an IP address, and I will come to know, hey, you know what, my refrigerator is full of, not full of milk, and today is a Saturday, Diwali, guests are coming, I need to prepare a tea, the milk needs to be available in the rack, but I'm out and I don't know whether I have milk or not. Before going to home, I should buy from any kind of grocery shop and fill it. That takes time, that takes thinking, like whether imaginations also. But if you look at what Alexa is doing these days, right? Alexa is for perfect device of an IoT. For example, Alexa is connected to the internet, and Alex, hey Alexa, and Alexa immediately start listening. Alexa immediately open the Amazon, not any other browser. Alexa, can you buy the diaper for my son? Alexa, just go to the Amazon.com, take the best offer, put it in the list, and say it delivered to the home. They're making the business model. They have all the integration with along with that. So if you look at IoT device, whether it's a refrigerator or any kind of dumb devices become available on the internet and will be on the digital platform. Digital means not everything is connected to the internet. Now think about smart homes. As I said, smart homes is dumb devices become smart homes that go with IoT device, IoT, right? Smart homes create all the lightning and happening stuff with the help of devices, IoT. Like yesterday, Eknath Shinde and Fadavnis, they went to Raj Thakre and they put the light on and everything was shining, right? So they create this shining stuff or smart homes or smart lighting in Diwali fashion in Dadar, for example. This is what the data is generating in trillions of manner, right? And if you look at why we are doing and transforming into is action, insight, dashboards, and we are creating the services to the end users, to the businesses, to the CEOs and CIOs who can take decision where we are today, where we need to invest. Do I have enough data in my hand? Do I have enough processing in hand to go to that level? My competition is bringing X service, and I also want to bring that X service, but I want to be ahead of the curve. I want to implement before the, let's say if I want to, the Black Friday is coming right in November, and I want to sell more and more. I need to create service faster before my competition take that market share out. You have to be ahead of the curve. That kind of decision you have to take with the data. So you need to be sure that you have enough data, you process it, you are taking decision, and you're building the services or offerings on top of. The major challenge is, of course, every solution has pros and cons, right? My presentation also has a pros and cons. I'm not 100% perfect. Nobody's 100% perfect. There's always 80-20. I'm 80% good, 20% always room for improvement. That's the reason there is a 80-20. So 20% focus on the improvements, adding value, how we can be better and better every single day. So that comes with a challenge, right? I mean, challenge means we look at, as I said, there are five challenges which I personally think and I'm putting here. And I'm taking the science because day before yesterday, I was at the dentist and the clinic, and I thought life science is the best example to put it. So if you look at uh, data quality, and there was a lot of, I don't want to put name badly, but if you look at, there are five major challenges. Data quality, because as I said, whatever you should do, you as an individual student or CEO or anyone as an entrepreneur, whatever you do, because you're selling to the customer, that should be quality. Quality comes with price, because the more quality product you create, customer are willing to buy. Apple, why I'm buying Apple? Because I feel the best quality, best security. I feel that user interface is much better. I'm not saying the Android bad, just my point, understand my point. The quality is very important, but obviously when quality means, it should comes with the performance, right? What is my performance of my mobile, what is my performance of that application, which or the memory which I'm buying with that quality, are that in line with what I'm looking. So if you look at here, the life sciences, a drug, for example, if the performance means also comes with a time, right? Like for example, if the corona comes and there is a no vaccine available or drugs available, how you can develop fast those drugs and make sure that you bring it to the life sciences or the patients, and make sure that everybody is cured at the end of the day. That performance really matter, whether it's a government performance, whether the medical suppliers or anyone who's doing the entire ecosystem, they should have highly performant way of looking into it. If you look at data exchange and collaboration, as I said, data exchange goes multiple ways, right? Patient, if a patient one transfer from one hospital to another in a critical situation, the entire data of that particular exchange should be known. For example, day before yesterday, or I don't know, there is a Sirsat who's an MLA been attacked. He transferred from X location to the Mumbai. That doctor will not operate unless he knows the patient X history, what they have done, what kind of things they have given, right, before they can do an angioplasty. So all those nitty-gritty steps really need to be known, and it should be in a collaboration fashion, right? Data management and scaling. Obviously, you're collecting the data. You need to have the data management tools and the scale. Scale means adding more and more, and you don't basically come with, hey, I have no enough data storage. You shouldn't come to that level. So you should have data platform like Azure, where you don't need to worry about the skill. You can add a number of data. There is no shortage of data anymore. But as I said to you, like Indian Compliance Act, Regulator Act, the data should make sure that the history of that patient should be kept secret. It should not be violated to any other user, because it should be bound between you and a hospital, right? Or consumer, or the company who is basically doing all the treatments. Not anyone should know, because you are getting married tomorrow and say somebody said, hey, you know what, you had a cancer, or you had something, and that data is leaked, your marriage is broken. Just an example, right? So all that critical data is very important for you not to give it to someone hand. And it's important, right? And what they don't have is a time, right? The important thing here I mentioned is the time. Data you have it, but sometimes time is very short to bring the outcome. Okay, so we talked about everything. So what is data, right? Data is in different form. Like I said, it's a structured. As I said, structure means there are tables, there are columns, rows, and everything is correlated. The Joe Jones, for example, has email address and mails. So columns are an attributes, right? And the information, like the data is part of the information, but we are collecting lots of information about the college students. Big exams are coming. Okay, let's say, what is the roll number of Dr. Arti, madam, for example? If she's a student, what is her name, what is her email address, what is the roll number, where is the the exam room, first floor, second floor, room number, desk number, all that's nitty gritty stuff that comes with proper structure. That is called structured database. SQL is a structured database, right? When you talk about semi-structured, which is like JSON or XML file, which seems like a structure, but still you do not know like how it is correlated. If you're not a coding guy, you do not know how you correlated New York City versus this number. You don't know, right? Because you cannot correlate. That is semi-structure. There has structure, but you can't properly bring to this level where you can everything is correlate. And there is unstructured. What is unstructured? The file, the messages, the videos, the name it, right? All the raw data comes is an unstructured form. So these are three main data types: with structure, non-semi-structure, semi-structure. And then question is where to store the data. The data you can make a file or folder and put the data maybe into the JSON file. You say, hey, my JSON cores are in the GitHub, but I make a file or my YAML file. So I said, hey, amar.yaml or whatever extension I give it, you give it. So you create that file, right? And that file or XML or JSON base or even non-delimitated delimited text, you can put it into file format. But that is also, file is also storage, right? Or my database, as I said, is a structured database which has tables, columns, and rows. You put into relational database because everybody has a relation. Jones, the address has a relation with Jones. So that is correlated, right? Tightly related, you can say that. So obviously now we talk about structure, unstructured, semi-structured. So big data, probably you said, hey, where the big data name come from? The big data is a combination of structured and unstructured data, right? You cannot say big data is just the structured data or a relational database, but it also comes with non-relational database. You combine relational, non-relational is become your big data, right? And the important thing is how you drive that big data. You drive in three different ways, and it comes with three different V's. V's is volume, velocity, and variety. So, for example, volume means a size, right? What size is coming, right? Like terabyte, petabyte, etc. So I need to have the volume. Velocity, the speed, right? So need to look at the data I'm generating and coming. Do I have enough speed? Do I have enough velocity, or you can say the time to make it happen and stored and processed and bring the outcome to have that platform. And the variety, obviously variety means data coming from different sources, right? If mobile apps, the web server and some other sources it coming, and still you need to generate. and that combines your big data story. So I hope this is clear. Like, what is probably, that we're talking about big data, but what is big data is structured, unstructured, and then combined is become big data. If you look at data journey, obviously, as I said, data was coming in all sources. Like I said, databases, SaaS application, web service, file legacy, all you're combining. You are and that may be structure, unstructured, and then what you're doing, you're collecting, recording, creating visualized report, which I showed, like the bar chart, etc., etc. And then you're generating or gaining some insight for creating dashboards. So this is the data journey every customer is driving, every provider is driving, to make sure that we can take a call to see how we can do customer satisfaction much better. For example, my cable modem was down 2 weeks back, and they came to know there are not only one but many cable modems were down, and they already have, they're like, okay, in this city there are cable modem down, so this house number, these things. Before um, they notice that they already know that, okay, I need to push already package and basically deliver that new cable modem to the end user before end user pick up the call and to the call center and order it. That kind of things they already driving ahead of the customer. Before customer notice, they already notice it, and they work it out to resolve your problem. That is the data, the benefit of data and working on the data basically. Okay, so before we go on, like I said, the Azure practice, our offerings is very small, so I can take 5 to 10 minutes. But first you need to understand what is data, what the process, what is batch, what is online transaction versus transactional processing versus analytical processing. So if you look at transactional processing, right, transaction is what, like I said, you purchase or sell or you deposit, withdraw, all that happens transaction, right? The transaction really need low latency, high performance, because if you're paying the bills, if you don't pay within 5, the portal will say timeout, or transaction, you need to redo the transaction. You don't have time, you're traveling to the flight, and your wife said, hey, can you pay the bill before, because today is the last day. If you don't pay the fee of your student, then your son, then tomorrow we don't get admission, and I'm in the flight, I have to catch the flight and move there, and you need to do the transaction very quickly. The my point is, you need to have less time, more performant application to the end user, which is fully authentic, fully secure. You need to build that. But those kind of application you always build because it is SQL related, structured database, you build on the database. So transaction processing always build on the databases. Keep in mind, when we call about analytical, like online analytical processing, we talk about many other stuff, everything like streaming and all that is related to the processing stuff, right, behind the scene, that you have to build in data warehouse, because you need basically massive amount of storage where you build it, whether it is batch processing, whether it's streaming, or whether it's real time. You need more data storage, so you build on data warehouse. Without that, you cannot build your analytical process. You need to have the data lake. Some in the past, the people have the data warehouses, Hadoop as solution, or some were using different solution, right? But Azure has brought many solutions, which I'll come to you right away. So last on the on before I go to offerings, last is, there are also, like I said, the batch processing. What is batch processing? What is stream processing? If you look at batch, right, batch, if you look at the cars, if there is a traffic signal, every car stops there, right? The moment the signal is green until become the red, that slot of cars will move to the next signal. That is a batch. So if there are three signals, they go with batches. So it depends on the time interval, right? If the signal is for 1 minute, the car stops. The 1 minute interval, the car automatically move here. When the signal is on for 1 minute, those cars move to another traffic light. That is a batch processing. You're processing the batches further. Hope that is clear. And that is on the regular interval. If you look at the stream, which is continuously ongoing, yeah, continuously ongoing. And if you look at when you're watching the IPL match, and you're watching on the television or watching on the iPad, laptop, you don't want disturbances. You want to capture every single ball, the ball hit to the sixes or boundaries, you know, or it's no ball, all kind of real time stuff. You really need to capture that as a streaming processing. When watching YouTube video, Netflix, all is streaming, right? So those are the streaming industries where the data is very sorry, the latency sensitive data is very critical for their business. Obviously, that's the reason, as I said, data lake, where data house, you can build. Just an example, you have batch or streaming processing. What you can do, you in the existing, you're using data lake, which is Hadoop based, but now you use different solution, which I'll come to you in Azure. But in the past, you were using Hadoop as the data lake for streaming and batch processing. But in Azure, I'll come to know what tools you use. So this is now, so far I talked. I know 2 hours she has given. I'll take another 10 minutes and we have the lab for 10-15 minutes. So 2 hours session will be over. So what is Azure is offering? So if you look at Azure has data stores. So as I said, SQL is, I don't want to go, I repeatedly talk about structured query language that comes with two flavors, right? So you can build a database. So what you can do, when somebody said, hey, this is my requirement, I want to build a database, and I want to build in public cloud. But then you say, hey, what you want to build? You want to build infrastructure as a service or platform as a service? When it comes to the platform as a service, you go with managed service. Means you don't need to manage the operating system, the virtual machine, and etc. You manage only the database as your key application delivery. So what you do, you pay there for DTU based. So you DTU is the data transmission unit. The more DTU you have, the more price you pay, right? Here, when you say, you know what, I want to build my Oracle application or Oracle database on top of the virtual machine, I manage the virtual machine, the operating system patching, security patching, the operating system patching. I will manage it. But then I will go with VM and then I'll install and manage my own application. Obviously, that comes with cores, and the more core you purchase, the more price you pay. And that comes with three different editions, right? Web edition, standard edition, enterprise. The web edition is a bit cheaper, standard is obviously higher, a little bit higher than web, but enterprise is where you try to buy all the features related to it. Then the question comes to you, really, do you need all the features, or you're okay with the major functions which really want to perform for your business? Take those decision, because when you're taking decision for a customer building application, when you choose wrong, you're adding more cost to the customer, which is not good. You help customer to reduce the cost. So whenever you take a decision building any application, whether SQL or any other, also choose and pre-provision in a right manner. Don't just blindly choose and say, you know what, I'll go with the more is better. That's not works. You need to understand from customer. Always, whatever you do in your career, your own study, your own persuasion, think what is the impact you're going to add to the customer society. You're not doing for yourself, you're doing for someone. You owe someone. So do always for them, right? And make sure that you take the right decision. If you look, and the lab is based on SQL only, so that point is mentioned here. So small lab, how to install database, I'll show you nitty gritty stuff. Obviously, they as I said, SQL is Microsoft their own proprietary solution. People, they uh, love to have the customers migrating from Oracle, other database to the SQL. Of course, everybody wants business, right? But obviously, if customer said, hey, I don't want to use SQL, I want to use open source relational database management services, RDBMS, relational database, but open source. That comes with MySQL, MariaDB, and Postgres. These are three open source Microsoft supports. There might be different, but these are the more popular and more usable technologies. So if you look at, somebody wants to build LAMP application. LAMP means what? Linux, Apache, MySQL, and PHP based application. MySQL is the best option. If somebody said, I want I want to go to MariaDB, but it should be compatible to Oracle database. You go with MariaDB. If somebody said, you know what, I want hybrid nature, right? Relational object storage related, I go with Postgres. So understand the requirement. Somebody said Oracle compatibility, you should come in mind, hey, I should go with MariaDB. If somebody said, hey, I want hybrid with relational, obviously relational, because this is a relational database, but also want object storage, which can comes in any sort of files, these and that. So I should go with Postgres. Somebody said LAMP application, right? Because I already have that expertise, Linux, Apache's front end, and then PHP application I can drive. Then you go with MySQL. So these are the flavors and decision, and then these are the, as I said, it's a pass base. You don't, because these are managed services comes with a pass flavor, where you are not working on the operating system and maintaining patches, etc. So you focus on the core application for database services. This is very important. The Cosmos DB is a document DB, like MongoDB, and uh, every cloud product has their own document DB database, but Azure offers Cosmos DB. If you look at, if you want documents, graphs, any kind of store information, column family stores, you can take it. Or key value pair. Key value pair means the specific. Hey, when I create a virtual machine, what is key value pair? It's a development machine, virtual machine, production virtual machine, or test. You put all the key attributes, right? Key and value, and that key value database you can go with my Cosmos DB. Cosmos DB is fully managed service, but it also globally distributed database. That means it is already there in all the regions, and you can replicate without any problem. There is a scale, and basically this, whether it's mobile or gaming or any IoT application, this is the perfect, because there is enough scale. Enough scale is there. If you look at data engineering and analytics point of view, um, Azure has data factory. This is the first and foremost. When you're moving data from on-premise to the public cloud, you need to ingest and you need to put your data in the cloud. That first hit or wall comes is a data factory, which help you to transfer and transport data and act as a pipeline in between, right? So that is the ingestion point where you are ingesting, but it's also help you to do ETL process. ETL is extract, transform, and load process, and you can run data directly on data factory. I put the flow also for you to understand. If you look at, there are another way of data stores is like Synapses, Azure Synapses, Azure Databricks. Azure Databricks is not their own solution. Databricks is a company based on California. um, and what they do is they have the complete AI machine learning. It's a data platform, but they have lake house, and they have created the complete ecosystem with cloud providers. So they have the Azure data breaks, AWS data breaks, GCP data breaks, all that combined, same name, but the cloud provider name before. They provide the data platform. They have the data warehouse, machine learning, AI, all that fully integrated with complete ecosystem, as well as open source platform they have created. But obviously, that's a different package you need to go and adopt. So if you go to marketplace in Azure or GCP or AWS, you go under marketplace and you face that service. Yeah, which is completely like scalable. Spark and SQL. Spark and SQL, these are the, like I said, Hadoop has Spark. Spark has more way of low latency and giving high performance and data store kind of solution. And Databricks has come up with that, because the legacy solutions had so many problem in terms of getting works done, but also burning the cost. They want to minimize that. If you look at Synapses, analytics has SQL, Spark, and Data Explorer, right? All that combined, and you can build the studio with it, because that you get that experience, right? And that is what and basically what happens, this is fully data warehouse. If you look at the data warehouse which we talk, and I said I'll come to you, this is the Synapses one, which is completely SQL, but also data warehouse, where you completely dump your stuff, like majority of the stores, right? If you look at in Mumbai, or places like Shoppers Stop, or any kind of the stores there, like, right, when the stock is stock is getting off, they pull it from the warehouse. So there are warehouses built in where they put a lot of storage. When needed, they immediately go there and pick it up. So all that data warehouses, they, if you want to build it, you can build with Azure Synapses, for example. Azure SD inside is very important when you already have mix and match like Kafka for real-time processing, Storm or Spark or Hadoop, and you want to basically do an implementation of common Apache Big Data. Azure has created a SD inside basically um, not only platform, but as I said, the complete ecosystem and fully automated system, which is managed service. And you can use that because if you look at it's fully open source platform, right? Because all these are open source technologies, they combine together to bring the outcome. Now, obviously, the as I said, I forgot to mention this data breaks. It's why it's consumers are going to that because it's more than 10 times faster with price and performance. Because that's where we're lacking, right? We're burning more price, but also the time we want to bring the outcome was very limited. So they are bringing that performance very quicker and can support up to hexabyte of data which per day, which is massive scale they are providing. If you look at streaming, as I said, the streaming where, as I said, watching the cricket match in real time, you need streaming. So they have created stream analytics engine, and that stream analytics engine specifically customers who wants to go IoT solution, they basically go and start working immediately on the streaming analytics, where IoT solution you can start building from a scratch. As I said, I touched to you in the last slide, but if you want more specific, you can use that slide later. The last part before I go to the lab is understanding how the data warehousing work. For example, as I said, you initially what you do, you collect all the data from all the sources, you put on the data factory, which is the ETL process. You extract data, transform, and load. Then you put into database, right? Whether it's data lake or even structured data or data warehouse, you put into the database. You get that, you run your models, and you bring the outcome in terms of report, dashboard, or some sort of graphs. If you want to, you can add into that, right? So this process you can continue, but obviously it is correlated. You cannot move, just keep this relational or warehouse, because somebody needs to store your data, and then you write a model on top. You cannot skip one process and jump into another without, it will be like not a great pipeline, I would say. The another example of ETL specifically, if you look at data, like you are collecting data, different sources, external data, internal data from on-premise or multiple public cloud, and you want to ingest. So obviously there are people nowadays, if you accessing publicly all the data, the best public bucket is the storage blob, right? The object storage, blob storage. If you want to do the AWS, you put into S3 bucket. If you want to do clouds, Google Cloud storage. So that is the ingestion point, and that is part of your data factory. So data factory means it combines with the object storage and the data warehouse. You combine together, and you become make a data factory, and you can orchestrate together. Orchestrating meaning you manage completely from one single UI, but you also process it, you also provision it from, that is orchestration. Once the data factory orchestration done, you go to the analysis, where you sometimes you need to also authenticate, right? Because you don't want the data warehouse data should only go for analysis without authentication, because who really wants to access that? That authentication comes. Amar is the data engineer, and he should process it. He should have access to that. He should only authenticate and authorized, and then he can use the Power BI as a visualization tool to generate that outcome. Yeah. So, and last slide of the day um, as I have to talk basically is about security. As I said, without security, all the exercise we have done is no value. So security, just put an example of SQL database to be secure. You need network secure. That means the access list, the firewall rules to allow only legitimate traffic and deny the illegitimate unwanted traffic. Access management, which is allow only users who only manage the database or read the database. Threat protection, there are a lot of threats popping up, right? right? Bots are there, lots of things, and how you can protect on the perimeter, which is on the internet edge, with the defender or DDoS protector of Azure services. You can use that, combine it, and you filter that attack on the top before coming to the bottom, which is database service. Information protection: do not leak any information about what is in that database, what is the database type we are using, who is managing. Do not leak that information, is very important. Customer data, as I said, credit card information, you should not give that credit card number to any person who can reuse your credit card number and you unnecessarily pay, or customer unnecessarily pay. All those information you have to kept it, because you are basically regulated by this company, and you obligated. If you don't, if you make mistakes, you pay the penalty, you pay the fine. Like on this ISO 20001 or PCI is payment card industry data security, right? So banks, for example, is offering credit card, debit card, so they are regulated by PCI DSS. So that credit card information should be very secure. So it's bank responsibility, or credit card information like Mastercard or Visa or American Express, their responsibility to keep that customer data very safe. Because if they violate, something goes wrong, they have to pay heavy penalties. Plus your brand value, right? Your brand value becomes very problem. Like Facebook, sometime there was some hack, data leak. Facebook revenue got down. The guy like Mark Zuckerberg was 130 billion guy, now he reached to 60 billion guy, right? 70 billion he lost because of these issues. You can imagine how the impact is on your business. Now it's a demo, and then we are done more or less to open up the questions. So if you look at demo, I'm going to do is I'm going to do let me stop sharing for a minute before I uh, before, and I'll put my lab on. Do you have any question quickly, or everything is clear? Hello, can you hear me?
Yes, sir.
So far so good. Hello.
Yes, sir.
Okay, okay, okay. Now I'm just accessing my lab. Just give me a minute, and I don't take much time. I will just quickly build the database and show you how the Azure UI is look like, and then I think we can close the session. So just a second. I'm just log into my. Okay,
Is there anyone who's having any question?
okay. So let me share my screen back again.
I
Um,
wanted to thank Amar sir.
yeah, ma'am. I'm gonna run the lab now. Can you see my screen back again?
Yeah, I can see your screen.
Okay, so I'm just not going to take more than 10 minutes to showcase like the how to build the database, or how easy to go to different things. If you want to build network, you want to build storage, you want to build. So for example, look at now I'm on the portal, Azure portal. Yeah. Um, so sorry, I'm on Azure portal. You see like on the left side, there is a like burger menu where you can click, and you can see all kind of resources, like the SQL database, the Cosmos DB, the virtual network, which is VNet. You can build Active Directory. You can go advisor. All those things, billing stuff is there, cost management billing there. So all those things you can find it here. But if you can't find it, just put it like I want to build the database, so I put SQL database. So you just put SQL. You see database. I'm gonna go there. I want to build database. base. So what I can do, I create a database. So I simply click on the create. Once it is create, the first and foremost thing is like you need to add the subscription. I'm renting my lab because I'm paying minimal amount, so I'm using their subscription. I can use the existing resource group is something if you want to combine all the resources in one, compute, storage, etc., and then you club them. And why you need resource group? Because tomorrow if you want to remove the storage and compute with hundreds of nodes in it, you just remove the resource group, everything will be removed automatically. Rather than clicking hundreds of clicks to delete, you click one delete and your resource group is automatically take all the resources out. So that is benefit of resource group. When you talk about database, so for example database name, I'll put I just created, so I said data factory this name. If you look at server, I want to create new server rather than consuming, so I create a new server. I give the name, I build the lab, so I'll put ca lab. I just put the naming convention, just otherwise you said I'm watching something. Now I just put some names just to be sure that I can showcase lab database server, and then I put name 468, just name. Location I can keep because I'm using, why I'm putting locations name differently and looking here, because every location has a different pricing, right? And I want, because I'm using my own subscription, so I want to use minimal, because anyhow if I use this lab for hour or two, I still pay for 2 hours. So I'm using the resources which less costly. That's the reason I'm choosing the appropriate region where the cost is minimum. Also think about designing your solution. Think about where the cost is low. But obviously you do not want to take, this is the demo, right? But whenever, if the customer is in India, choose the India region probably, right? The Asia region, I think you select Asia, India is there. Yeah, Central India or yeah, Central India, there is a data center. But for example, if your customer in US, choose the US data centers because they are close to their geography. Yeah, that's also important when you choose the location. But now this is demo. I'm choosing the lowest price, so I'm using uh, East ES2. If you look at authentication, I'm going to use the SQL authentication where I'm going to put my username and password. So for example, lab admin, because I want to create that is 01 and then type P. Yes. Okay. Then I'm clicking on OK. So what I did, I created a server name, obviously. I put the location. Then I use the authentication as a SQL, which I want to put my own username and password. When I go and fetch that server, I should use my own credential. Obviously, you when you use identity access management, you can use that one. But this is I'm doing static as a part of showing how to build it when you are building in the first time. And once you build that, obviously you can go and create it, because but the only thing you need to focus on, the moment I click, before I click review and click, you already see the cost here. And you need to keep in mind like what things you are using. You like a virtual core, I selected two cores. The cost per virtual core is 180 multiplied by 2, that comes here, plus you take some cost per gigabyte, how to say, the storage cost, and then maximum storage you selected in GB, all that cost comes with. So basically CPU and storage cost, because database means you need storage, that combines the cost, it show you already before you create it. So you think, hey, you know what, I want to fine tune, which I can tell you how to fine tune for a cost, and you can reduce the cost later. So now what I'm going to do is I'm going to just one thing you have to choose here is general purpose. If you look at here, um, I'm using server SQL, no, yes, workload, production, which is fine. Yeah, this is general purpose. Make sure that when you're putting a demo, you put the minimal configuration. You don't want to burn like hundreds of core CPU and terabyte data, because you will be um, consuming a lot of cost. So keep those in mind. Otherwise, if you make small mistakes here, the bill which I get at the end of the day will be higher. So I go and create now, and automatically you just click on create. And within, if you look at the moment you click on create, what it does, it check behind the scene and said whether it's validated or not validated. The moment all the settings and all the things it says, it automatically pop up here. You see here where the alerts and everything there are notification. You see like what's happening when there is a number, something is happening, something. So you always have to focus on this portal to be sure that what is the status. Once it is created, it says deployment in progress and deployment will be completed. So you will see in a couple of seconds that the deployment will be complete and we are good to go. So good to go in terms of um, all the administration or fine tuning about that database. And if uh, you want to connect, like if it is SQL, you want to do like query and any kind of stuff like select star the table name, etc. All those things you can do it via PowerShell, and which can show how the PowerShell is. If you look at here, this is PowerShell where you go and you can even connect. You see now that date is accepted. The state is also changing, right? Now it is accepted and it will come to this. This will come as a completed. Obviously, it's a database. It takes a couple of minutes to fine tune and build in a way you requested for. Um, yeah, just bear in few for few seconds. It says in a minute, right? Deployment resource group. Yesterday there was a small problem which, yeah, you see now it is created. The status has changed from accepted to the created. You have to keep the and it will be say complete. Yeah, you will see that everything will be complete. So now everything is created. Yeah. If you look at, if you go to this created, you will, once you created, you will come to know, okay, this is my database created, and whatever the attributes are here, you can fine tune for this database. So for example, here you say active directory admin, which is not configured, so you can go and configure against the database. If you want to have defender, which is vulnerability assessment and threat protection, which I said defender is on the top, you can go and configure. So all this fine tune you can do it. If for example failure group, you want to automatically manage the replication. So if that database goes off, you can manage the replication from one place to another, or one data center to another, one region to another, all that geographic replication. But you have to configure it. That is the fine tuning, right? If you go back to properties, you see bunch of properties here. But important thing to look at is one second. If you look at here, if you want a networking and identity access management, it's disable. If you look at public access, disable. If you want to give public access, you have to select the network and you have to add those networks and only give that access to, right? So those kind of fine tuning, whether you should put public or non-public, also need to decide, because it's a database, you should not allow to the public. That's the first and foremost thing you should, it should come into your mind. Only uh, because it's a critical database, you should not violate to the internet. Auditing, for example, if somebody is doing auditing, like important to look at how you are collecting the use of Azure monitoring to collect all the resources, and you are giving the auditing stuff, whether data related events or rights, all things you have to keep in mind that you are properly configuring and fine tuning. If you want to take a backup, you can say, you know what, I want backup. Let's say this is the backup now, I put it, but you want to restore that backup if it is disaster, for example. So there is a RTO and RPO. Basically, when you design, you always ask RPO what is the um, recovery point objective, recovery time objective, and you design your database accordingly. So when you design, that's a design question, that's the architecture question. You need to think about how you fine tune and then you build it that way. And if you want to access any kind of, let's say, the SQL database on the bash, so what you can do is basically what happened. Yeah. So click on the bash, then you show the advanced, and you create a storage. So storage account name use, you can use existing. And the important thing is, um, yeah, so storage account you can use existing, but the thing is, why it's not saying strange. So this is a problem yesterday also occurred. Anyway, I don't go into that bash cell, but you can imagine, right? If you want to add all the or manage your data base, you can do all the things. You can create logs, you can generate logs, you can even automate your database. Any kind of encryption you want, you can add it. You can import export if you want. You can say, you know what, I want import export, and you can use that facility. Failure groups, you can add it. If you want to delete the database, you can delete it. So for example, you go back and say you said the deployment complete, and go to the resources, for example, and you want to remove that database. So what can you go here and click on delete database. So what you can do, you see, you don't want anything, you just keep his feedback, and you click delete. So use that name, for example, data factory. Oh, sorry, what you use this name. So use this name and just delete it. So what it says deleting a server. So even if you want to delete, because after delete my billing will stop, I won't be able to pay for next 1 hour. I only be paying for this 1 hour. 20 minutes is actually calculated as a 1 hour. So I only be paying for that. But you said like some of the services that are free for month, you can use that. So like I said, there are so many services here, Kubernetes services, app services. So you have the burger menu where you can look what functionality you want to build. And it's very easy, and very, like I said, Microsoft is always user friendly. They always have the description on top. If you click on virtual machine, there's always a description is there. If you look at virtual machine, there is a description like, hey, create virtual machine, run with Linux, Windows. Simplified, everything is written. So even if you're blindly doing, first time doing, sorry, you can clearly read it. You don't need to note. So everything is properly written. Networking, then you unique network interface card, all those things are there. And I think that is why cloud become more popular, more user friendly, and the future of every infrastructure. So that's all for today's from the lab point of view. Just the lab is done, and like I said, what I was wanted to is create a SQL database and access from the cloud shell. But cloud shell, I think there was the use existing feature. This morning is work, and again it was not working. I don't know what happening behind the Azure. To basically, what I wanted to show is I created database. I wanted to upload a file and basically use from the shell to pull the data out of the table. But unfortunately, the is not working. Apologies for that. And last but not least, you are going to be a future let's say leaders or technologists. So what your roles will be if you really want to move into the data professional team. So you will be either doing database administrator, that means managing the, like say, creating database, which I just did, provisioning, configuration, etc. So what exactly I did for database management, security, backup, etc., that you will be doing if you take that path. If you take data engineer, you will be working on data, like collecting data, processing is like collect data, processes, curate it to generate all the insight like dashboard, etc. So cleaning, transforming all those, writing schemas and everything in a manner where you need to bring the outcome to the customers or your team or your C-level people. That's a data engineer job. If you look at data analyst, obviously you are working on modeling, right? Which I just showed, like what are the different modelings are there, visualizations are there, graphs, charts, pie charts, whatever you name it, you'll be working on this. So these are the roles as of today and will be in the future. Um, the names might be different, but the underlying roles and responsibilities are more or less the same. With that, I would like to say thank you. And if there are open questions, I will take it. If there is no question, everything's clear, is happy also. But if there are questions, please move on.
It was awesome to see the Azure platform. I worked a little bit about this on AWS, but looking at the Azure platform, it is very wonderful. I hope if there is any question, please student ask. I think Amar sir, your explanation was so simple and so nice. So there is no, I think there is no question. But definitely we are going to practice on Azure. And if there is any like help we want, we will be definitely connecting you offline. I will be sharing your email ID with them, so or they can connect with me and then I will forward you the question. So it is
Anytime.
wonderful. It is wonderful for just a word, and you accepted my invitation all the way, getting up early in the morning from Netherlands. It is really awesome. I wanted to thank you personally, and I hope we will have some good and great sort of collaboration in the upcoming years. Looking forward some internships, some projects where SPIT students will serve with you. Thank you very much,
Absolutely.
and happy
Absolutely.
Diwali. Yeah.
Happy Diwali to you, ma'am, and everyone. And stay in touch. Reach out to me LinkedIn, by email or WhatsApp. Um, and if you need any like career guidance or anything, happy to connect with you. Yeah. God bless you and stay in touch.
I wanted to congratulate Amar sir in front of everyone because yesterday there was a good news for him that he got selected as a director. And this is like we are having some positive vibes in the upcoming days also for you all. So thank you very much, sir. And to my dear students, thank you very much for joining Saturday. So thank you very much.
Thank you. Yeah, it's important that they took a time to join. So thank you all. I hope this this conversation was useful to you, and hope you learned something. I learned also many things while preparing because obviously I know from the knowledge point, but when I'm creating slides, also I was thinking how can I create from your eyes, not my eyes. So yeah, yeah, that thank you for giving me an opportunity also.
Thank you, sir. Thank you, Rahul. Thank you, ACE committee.
Thank
And
you.
thank you, my doctor students.
Thank
Thank you,
you.
sir. It's all our pleasure.
Thank you. Have a good day.
Yeah. So, students, you have to fill out the forms which are in the chat. So, it's mandatory for all of the students. So, please fill as soon as possible.
Okay, sir. Can I take out or I have to stay here?
No, sir.
Yeah,
You,
we
you
can conclude the meet. Yeah, we can conclude the
Okay.
meet.
yeah,
Thank you
yeah.
so much. Thank
Thank
you.
you. Thank you.